In the name of Almighty God, the most compassionate and the most merciful, I welcome you all to your own channel. Today we will have our fourth lecture on binomial expansion. I hope that you have seen the previous three lectures. Today we will have our best lectures and starting from question 19. By the way, pick up a notebook with a pen. Whenever I write the question, please pause the video, then start the solving by your own self. If you couldn't, click on the button of the play and you will watch how I solve the question. By the way, we have question number 19. Prove that the coefficient of x to the power n 1 plus x raised to the power 2n is twice the coefficient of x to the power n 1 plus x raised to the power 2n minus 1. How we can solve this question? First, I have to say that whenever we talk about 1 plus x raised to the power 2n, now what is the expansion of this binomial expression? I think it is 2n c0 1 to the power 2n, and 1 to the power every number it's 1, so I would not write the 1, plus 2n c1 x to the power 1, then 2n c2 x to the power 2, and like this one. Now what do you think if we are talking about x square? Now what is the coefficient of x square? It's 2n c2. If we talk about x to the power 1, what is the coefficient? 2n c1. If we talk about x to the power 3, now what is the coefficient? The coefficient of that one would be 2n c3. This is the coefficient for x cubed. Like this, if we talk what is the coefficient of x to the power 10, then it is 2n c10. Am I right or not? Yes. If we talk about coefficient of x to the power 20, it is 2n c19. Like this, if we talk what is the coefficient of x to the power n, I think and I'm sure that is 2n cn. For x to the power 2, it is 2n c2. For x to the power 3, 2n c3. For x to the power n, it is 2n cn. Am I right? Yes. And this 2n cn, it means 2n by n. Now if you simplify this one, it is 2n factorial, this minus this, 2n minus n factorial times n factorial. And if you simplify this one, it is 2n factorial divided by 2n minus n, it's n factorial times n factorial. Am I right or not? Yes. I mean the coefficient of x to the power n 1 plus x raised to the power 2n is 2n factorial divided by n factorial times n factorial. I will write this one in a box. Now this is our first box. Like this one, if we talk about 1 plus x raised to the power 2n minus 1, now what is the expansion for this one? I think it is 2n minus 1 c0 plus 2n minus 1 c1 x to the power 1. I would not write 1. And why? Because 1 to every power is 1. 2n minus 1 c2 x to the power 2, like this one. So if I ask you what is the coefficient of x square, is 2n minus 1 c2. What is the coefficient of x to the power 1? It's 2n minus 1 divided by 1. What is the coefficient of the x to the power 3? 2n minus 1 c3. It means in here we don't have any change, but this index is, if we talk about x to the power 3, this is 3. If we talk about x to the power 5, this is 5. Like this one, if we talk about x to the power n in this one, so it would be 2n minus 1 cn. We don't have any change in here, but we have the change in indexes. in this index. If we talk x to the power 1, it's 1, x to the power 2, 2, x to the power 3, 3. If we talk about x to the power n, it's 2n minus 1 cn. And if you simplify this one, it means 2n minus 1 by n, and the formula we can use for this one, it is this factorial, 2n minus 1 factorial divided by this minus this, 2n minus 1 minus n factorial times n factorial. If you simplify this one, it would be 2n minus 1 factorial divided by 2n minus n. It is n minus 1 factorial times n factorial. Am I right? 2n minus n, it is n minus 1, this is minus 1 factorial times n factorial. This is the coefficient of x to the power n for the 1 plus x raised to the power 2n minus 1. So this is our second box. Now the question is, you have to prove that the coefficient of x to the power n for the first box, this should be twice the coefficient of x to the power n for the second box. It means this one should be twice of the second one. How can you prove? Let me see. For the second box, we have 2n minus 1 factorial divided by n minus 1 factorial times n factorial. Am I right or not? Yes. If you let me, I will write here 2n and 2n. I want to say the numerator and denominator I will multiply with the same number of 2n and 2n. Is it correct? Yes. Why? Because we can cancel this one and the remaining part is our second box. Now look here. If I want to write this one, 2n times 2n minus 1 factorial, can I write the numerator like this one? Yes. Obviously we can. Now in here, if I want to say this 2n, just I want to put n in front of the first box, n minus 1 factorial times n factorial times 2. Can I write it like this one? The denominator? Yes. 2 times n is 2n and the remaining part is our remaining part. Now look here, this is 2n minus 1. Is this one 2n factorial? Yes, it is. Why? If you simplify this one, the simplification for this one, it is 2n times 2n minus 1 factorial. And if you look here, is this one n factorial? Yes. Why? N factorial is n times 1 is decreasing, n minus 1, like this one, n minus 2, n minus 3. And we have another n factorial times 2. What do you say? Is this one our first box? Or this one? Yes. So it means that the question is our second box is, and this is our first box divided by 2. This is our first box and this is our second one, this one. Now if you multiply cross, so you will have, what's the denominator for this one? It's 1. 1 times the first box is 2 times of the second box. Now what does it mean? Our first box is this one, and this is the coefficient of x to the power n. It means the coefficient of x to the power n in our this binomial expression is twice of the second coefficient of the 1 plus x raised to the power 2n minus 1. I think you have got. Write it please. Question number 20. Find a positive value of m n 1 plus x raised to the power m, for which the coefficient of x square is 6. It's a simple question. How you can solve? First, if you want to talk about 1 plus x raised to the power m, what is the expansion for this one? It is mc0 plus mc1 x to the power 1, mc2 x to the power 2, mc3 x to the power 3, and dot dot dot. Now the question is the coefficient of x square. This is x square and this is the coefficient. The coefficient of x square is mc2. It should be 6. This is 6. Now this is a simple equation and you can simplify. What does it mean? It means m factorial divided by this minus this, m minus 2 factorial times 2 factorial, 6 equal to 6. Now you can simplify this one up to m minus 2, m minus 1, m minus 2 factorial divided by m minus 2 factorial times, and 2 factorial means 2, equal to 6. This is cancelled. Now you can multiply, cross multiplication. What is the denominator for this one? It's 1. 1 times this one, it is m square minus m, and 2 times 6, it is 12. Now this is a second order equation. So m square minus m minus 12 equal to 0, and you can have the factor of 12 4 times 3, it is 12, and this one says minus 4 minus 3, it is the coefficient of the middle term, and this one says the signs should be different, and this one say that you have to select the biggest one minus and the smallest plus. Now you have two factors, it's m minus 4, m plus 3 equal to 0. The multiplication of two brackets are when 0, they are 0 if at least one of them must be 0. So this one, it is 4, and this one, it is minus 3. They have said that you have to find a positive value, that is 4. Write it please. Question number 21. Find a, b and n in the expansion of a plus b raised to the power n if the first three terms of the expansion is 7 to 9, 72, 90 and 30, 375. How you can solve this one? By the way, first, whenever you're talking about a plus b raised to the power n, what is the expansion for this one? It is n c0 a to the power n plus n c1 a to the power n minus 1 b to the power 1. The next term n c2 a to the power n minus 2 b square plus dot dot dot. Am I right? Yes. Now the question is the first three terms. This is the first one, this is the second one, and this is our third term. These three first terms should be, the first one should be 729, the next term 7219, and the third one should be 37, 5. Now I mean the first three terms, I mean nc0 a to the power n should be 729. This is our first equation, and this one means n by 0, it is 1. 1 times a to the power n, a to the power n, it should be 729. This is our first equation. Second one, the second term, which is nc1 a to the power n minus 1 b to the power 1, this should be 7290, and this one means n by 1, this is n, and a to the power n minus 1 b to the power 1 should be 7290. And if you simplify this one, it would be a to the power a to the power minus 1 times b is 7290. And if you simplify a to the power b divided by a, this a goes to denominator. Now 7290. This is our second equation. Our third equation is here. C2 a to the power minus 2 b square, it should be 37 5. Now if you simplify here C2, it means n factorial n minus this n minus 2 factorial times 2 factorial. And if you simplify this one, it would be n minus 1 n minus 2 factorial divided by n minus 2 factorial times 2 factorial means 2, and you can cancel this one, so it would be n minus 1 divided by 2. I mean, instead of this one, you can write what? You can write n minus 1 divided by 2 times, this one would be a to the power a to the power minus 2, and this minus 2 comes to this denominator, b square divided by a square equal to 37 5. This is our third equation. Now what do you see in these equations? We have three variables. First one is a, second one is n, and the next one is b. And we have for three variables three equations. Now you can simplify, and simply you can find the value of the n, a and b. What do you think? The first equation, our second equation is in multiplication and division. Our third equation is also in multiplication and division, and this one a to the power n itself, this one is also in multiplication, so it means a. If you have your two variable or three variable equations in multiplication or division, you can simplify the equations by dividing on each other. I mean, if you divide the second equation with the first one, if we divide our second equation by first one, what do you have in second equation? You have n a to the power n b divided by a. This one divide by the first equation, which is a to the power n is equal this one 7290 divided by 729. Now it is cancelled, so you have n times b divided by a is equal, if you divide these two, I'll write here n b divided by a. If you multiply this, if you divide this one, it would be 10. This is our first star equation. N b divided by a is equal to what? N b divided by a is equal to 10. Am I right? Yes. Yes. Yeah. Now if you divide the third equation with the second equation, third equation divided by second, what's our third equation? It is n minus 1 divided by 2 times a to the power n b square a square. It should be divided by second equation, n a to the power n b divided by a equal to this one 37 5 divided by 7290. Now this a to the power n is cancelled, this one with this one, 1b with 1b, and 1a with 1a. What the remaining part is What the remaining part is? It is n minus 1 divided by 2. N minus 1 divided by 2 in where? In numerator we have n minus 1, we have b in numerator and a in denominator. This one. Other terms are cancelled and is equal to now you can cancel this one also. 37.5 divided by 72.90. Am I right? Yes. I will cancel here 37.5, 72.90. It's cancelled by 9. 8 times 9, 72. 1 time 0. In here we have 3 9 27. The remaining is 33. 3 9 27. We have 67, and we have 7 times 9, 63, and we have 4 5. And this is cancelled by 5, so you will have 1 5 is 5. We have 31. 6 5 is 30, and we have 10 2 5. In here 6 times 5 30, 37. We have 7 times 5, and we have 25. 5 times 5, and we have another cancellation by once again with the 9. So you have 1 times 9 is 9. We have 72. 8 times. In here you have how many times? I think 7 times 63. We have 45. 5 times. And once again you will have a cancellation with the 3. 3. 6 times 3 is 18. 6 times 3 is 18. In here we have 2 times 3 is 6. We have 15. It is 25. Now we don't have any cancellation anymore. So the result by dividing of these two terms is 25 divided by 6. 25 divided by 6. Am I right? Yes. If you see here, this equation can be changed. B divided by A, this n comes to the denominator of 10. 10 by n. I mean, in here we have n minus 1 divided by 2, and instead of this one, you can write 10 divided by n is equal to 25 divided by 6. You can cancel 2. We have 5. In here we have 5. So you would have n minus 1 divided by n is 5 divided by 6. Now you can use cross multiplication. 6 times this one is 6n minus 6, and we have 5n. And if you want to solve this one for n, this 5n, put it to the left side. 6n minus 5n, it is n, and minus 6 to the right side, it is 6. So n is 6. We have found the n. If you put n in the first equation, you will find a. A to the power n is 729. And instead of n, you have to put 6. A to the power 6, you have 729. Now take the root 6. So you will have this one, and root 6 and 729, it is 3 to the power 6. Am I right? Yes. We can cancel this one. So a would be 3. Now you have the value of a, value of n. If you put in anywhere, you are able to find the b. If I put here, instead of n, 6, instead of a, 3, now you can find the value of b. And b divided by a is 10. This is our first star equation. And instead of n, you have 6 times b, instead of a, 3, is equal to 10. 1, 3, and 2. 2 times b is 10. If you divide both sides by 2, so you will have b is 5. A is 3, b is 5 and n is 6. Write it please. Question number 22. Find a if the coefficients of x cubed and x squared in this expansion are equal. By the way, it's a simple question. Whenever you are talking about 3 plus ax raised to the power 9, what is the expansion for this one? It is 9c0 3 to the power 9, am I right? Plus 9c1 3 to the power 8, ax to the power 1, 9c2 3 to the power 7, ax square, and 9c3 3 to the power 6, ax raised to the power 3 plus dot dot dot. Now the question is the coefficients of x cubed. In here we have x cubed and x square. In here we have x square. They are equal. What do I mean? 9c3 3 to the power 6 a cube x cube, this one. The coefficient of x cube is 9c3 3 to the power 6 a cube. It is equal with the coefficient of x square. What the coefficient of this one is? 9c2 37 a square times x square. This is the coefficient of the x square. This with this one is equal. So it is 9c2 3 to the power 7 a square. Now you can cancel 3 to the power 6 with 6 of this, and you can cancel this one with the second power of this one. So the remaining is 9 by 3, which is 9 factorial. 9 minus 3, it's 6 factorial times 3 factorial times a. We have in here 9 factorial, and we have 9 minus 2, 7 factorial times 2 factorial times 3. This 9 factorial and 9 factorial is cancelled. And what do we have? We have in here 1 divided by, in here 6 factorial times this 3 factorial means 3 times 2 factorial times a. In here we have 1 divided by 7 is 7 times 6 factorial times 2 factorial and times 3. 2 factorial with this 2 factorial and 6 factorial with this 6 factorial. Now this 3 goes to the nominator, so you will have a 3 times this 3, it is 9 divided by what we have in denominator. In denominator we have 7, so a should be 9 divided by 7. Write it please. Question number 23. If a and b are distinct integers, it means if a and b are two different integers, like 2 and 3, like 5 and 6, but we cannot have 5.1. Why? Because it is not an integer number. Prove that a minus b is a factor of a to the power n minus b to the power n whenever n is a positive integer. How you can solve? What do you think? Before solving of this question, if I ask you, is 2 a factor of 6? You say yes. Why? Because if we factorize the 6, we have 2 times 3. It means we have 2 and 6. For this result, 6 is divisible by 2. Why? 6 is 2 times 3 divided by 2. This 2 with 2 is cancelled, and the remaining part is an integer number. If the remaining part is not an integer number, on that occasion, then 2 is not the factor of the 6. For example, if I want to talk 15, is 15 divisible by 3? Or we can ask, is 3 a factor of 15? You say yes. Why? Because 15 is 3 times 5, and this 3 times 5, this 3 is in 15. I mean that if we cancel this 3 and 3 is cancelled, and the remaining is an integer number. But if I ask you that is 3 the factor of 16, you say no. Why? Because in 16 we don't have 3 times of an integer which is divisible by 3. I mean 3 times something we have, which is 16. We have 3 times something, but this something is not an integer number. It is a decimal number. I'm sorry, it would be a fraction or decimal. In here, if you want to prove that a minus b is a factor of this one, so you have to know that a to the power n minus b to the power n, it should have the multiplication of a minus b with something integer number. On that occasion, a to the power n minus b to the power n is divisible by a minus b. I think you have got the question. Now, how you can solve? It's simple. Listen please. If I want to write a, can I write this one a plus b minus b? Yes. Why? Because this b with this b is cancelled and the remaining is a. Can I write this one like b plus a minus b? Yes, we can write, because plus, if multiplied this plus or positive with this bracket, so this b with this b is cancelled and the remaining is a. Now, if I want to talk about a to the power n, what a to the power n is, you say that if you want to raise this one to the power n, you can raise this all terms to the power n. B plus a minus b raised to the power n. This is a. This one is a to the power n, this is also a to the power n. Now if I say this one is x and this one is y, now look, x plus y raised to the power n, is this one a binomial expression? Yes, it is. Now if this one is a binomial expression, how you can simplify this term? I think you can simplify this one. N C0, this x to the power n, I mean b to the power n, plus n C1 b to the power n minus 1 times y to the power 1, I mean a minus b raised to the power 1. We have plus n C2 b to the power n minus 2 a minus b square, plus n C3 b to the power n minus 3 a minus b to the power 3 up to n Cn, this one b n minus n and a minus b to the power n, a minus b to the power n. Ncn, it is 1. I do not want to write it. In here nc0, this is also 1. So we have the expression for this one is this. Now we do not talk about a to the power n, we want to talk about a to the power n minus b to the power n. I mean a to the power n minus b to the power n. So what a to the power n? The a to the power n is this expression, I mean b to the power n plus nc1 b to the power n minus 1 a minus b raised to the power 1 plus nc2 b to the power n minus 2 a minus b raised to the power 2 plus nc3 b to the power n minus 3 a minus b raised to the power 3 plus dot 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 up to a minus b to the power n. This one is our a. We have minus b to the power n. Now we can write minus b to the power n. This b to the power n with this b to the power n is 0. It's cancelled. So we have a to the power n minus b to the power n is, in here look, we don't have this one, and we don't have this one. We have a minus b to the power 1, a minus b to the power 2, a minus b to the power 3, up to a minus b to the power n. What is the factor between all these terms? We can have the factor of a minus b to the power 1. The remaining part is nc1 b to the power n minus 1. Am I right? Yes. Plus nc2 b to the power n minus 2 times a minus b raised to the power 1. Why? Because we have get the factor to the power 1, and this is 2. 1 is factor. And next one, nc3 b to the power n minus 3 times a minus b raised to the power 2 plus dot 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 up to a minus b raised to the power n minus 2. Now what do you think? Do we have a minus b as a factor in the multiplication of the a minus a to the power n minus to the b to the power n? Yes, we have. So this one is cancelled with this one, and this remaining part is a positive integer number. Why? Because n is a positive number, n by 1 it's 1, and b is a positive number, this is a positive number, and this is an integer number. This one is also a positive integer number, which you decrease this one by 1, we have once again an integer number. If you simplify this one, this is an integer number, and this is cancelled with this one. So we can say, or we can say that the a minus b is a factor of a to the power n minus b to the power n. Hence it is proved. I think you have got. Write it, please. Question number 24. Find n if the ratio of the fifth term from the beginning to the fifth term from the end in this expansion is root 6 divided by equal, or root 6 ratio with 1. How you can simplify? First, if you want to find the fifth term from the beginning, our expression is root 4 2 plus 1 divided by root 4 of 3 raised to the power n. In here, what do you have? N is n, x is root 4 2, y is 1 divided by root 4 of 3, and you don't have r. If I say the fifth term is happening in tr plus 1, the fifth term is happening in tr plus 1, I mean the tr plus 1 is t5. So r plus 1 is equal to 5, r is 4. Now how we can simplify tr plus 1? It is tr plus 1 is equal to n cr x to the power n minus r y raised to the power r. In here we have tr is 4, 4 plus 1 it is 5, n is n, we don't know, cr it is 4 times x, x is this one, root 4 of 2 raised to the power n minus 4, y is this one, 1 divided by root 4 of 3. Am I right or not? If you simplify this one, can you simplify this one? Yes. We have what? We have t5 in here. This one means n by 4 times this one is 2 raised to the power 1 divided by 4 raised to power n minus 4 times, and this one is 1 divided by 3 to the power 1 3 to the power 1 divided by 4, and you can put this one in numerator, so you will have 3 to the power minus 1 divided by 4. This is our you can simplify this term also in here. T5 is equal to n by 4. This 1 divided by 4 can be multiplied with this power, so it would be 2. 1 divided by 4 times n, it is n by 4, minus 1 divided by 4 times 4, it is 1. 3 to the power minus 1 divided by 4. This is our fifth term from the beginning. How you can find the fifth term from the end? How we can define the fifth term from the end? From the beginning it was easy, but how you can define the fifth term from the end? Simple. I will show a way. If you want to talk about a plus b raised to the power 3, if we talk about this one, now what the expansion of this one is, it is a cube plus 3 times a square b plus 3ab square plus b cube. Now what is our second term from the first? It is 3a square b. What is our second term from the end? It is 3ab square. Now if we want to talk about second term from the end, just change the place of b and a. b plus a raised to the power 3. What is the expression or expansion for this one? It's b cube plus 3b square a plus 3ba square plus a cube. Now this is our second term from the beginning, which is equal to the what? To the second term in this one from the end. If I want to talk, what's the second term for this one from the beginning? A and b. What is the second term from the end? Just change b and a, then find from the beginning that term you find. This is the term from the end. I'm sure you have got. Now in here, if you want to find, this is the fifth term from the beginning. From the end, just change the what? The place of x and y. I mean 1 divided by 4 root of 3 plus 4th root of 2 raised to the power n. Now define the fifth term from the beginning with this formula. That is the fifth term from the end. I mean in here, once again, you want to define T5, and T5 is TR plus 1. So R is what? 4. In here, T5, it's from end. NCR, NCR is 4. X, this is X. 1 divided by 4th root of 3 raised to the power n minus r. N is n, r is 4 times y raised to the power r. Y is 4th root of 2 raised to the power r. R is 4. Am I right? Yes. In here we have something, I think. Y raised to the power r. What is y? 1 divided by this one. R. Where is r? R is 4. You have to put 4. You have to put 4. And this 4 with this 4, it's cancelled. So you have minus 1. I'm sorry. Am I right? Yes. Yeah. Now if you simplify this one, this is cancelled, so you have t5 is, this one means n by 4, and this one is 3 minus 1 divided by 4 times this one, n minus 4 times 2. Am I right? t5 is n by 4, this is 3, 1 times divided by 4 times this power, it is minus n divided by 4, minus with this minus is plus, 4 with 4 we can cancel, we have 1 times 2. Now the fifth term from the beginning divided by fifth term from the end is root 6 divided by 1. This is the ratio. Now what is the fifth term from the beginning? From the beginning, this one, n by 4 times 2 raised to the power n minus 4, n divided by 4 minus 1 times 3 raised to the power minus 1 divided by this one, n by 4 times 3, we have minus n by 4 plus 1 times 2. Root 6 divided by 1, it is root 6. We can cancel this one. In here, this 2 with this 2, the bases are same. So you have 2n minus 4 minus 1 minus this power minus 1 times 3. In here, these two bases are same. So this minus 1 minus this power. Minus with this minus, it's plus n by 4, minus with this one, it's minus 1, and this one is 6 raised to the power 1 divided by 2. Now you have what? 2n divided by 4 minus 1 minus 1 minus 2 times 3, this n divided by 4 minus 1 minus 1, it's minus 2, is equal to 6 divided by 6 raised to the power 1 divided by 2. Now the powers are same, so you can have from the power 1 term n by 4 minus 2, and the bases should be multiplied. 2 times 6, it's 6, 2 times 3, it's 6, equal to 6, 1 divided by 1, 2. Am I right? Yes. Now according to exponential, the bases are same, so the powers must be same. I mean n by 4 minus 2 should be 1 divided by 2. If we multiply both sides by 4, so you have n minus 8 and this one is 2. Put minus 8 to the right side, so you will have n 10. Write it please. Question number 25. It would be our last question for this lecture. Find the independent term of x in this expansion. I mean that if you expand this expression or this binomial expansion, now in which term up to how many terms does it have? It has 16 terms. Am I right or not? Now which term it has no x, or which term is independent of the x variable. By the way, how you can define? First, if I write 3x squared divided by 2 minus 1 divided by 3x raised to the power 15, in here n is 15, x is 3x squared by 2, y is minus 1 divided by 3x, and we don't know r. If we define the r plus 1 term in this expression, it would be ncr x to the power n minus r, y raised to the power r. Let that independent term occur occur in odd term n, or this one, r plus 1 term. Now it would be t r plus 1 is equal to, instead of n you put 15, c instead of r we don't have, times x is 3x squared divided by 2, 3x squared divided by 2 raised to the power n minus r, 15 minus r, times y is minus 1 divided by 3x raised to the power r. Now if you simplify this one, it would be 15 cr, this 15 minus r belongs to 3 by 2 and also x squared, I mean 3 by 2 raised to the power 15 minus r times x squared raised to the power 15 minus r. Am I right? Yes. In here we have minus 1 divided by 3 raised to the power r and 1 divided by x raised to the power r. And instead of this one you can write x to the power minus 1. Now we have tr plus 1 is equal to 15 cr. This one is 3 by 2, 15 minus r times x. This 2 is multiplied with this power, 2 times 15 it's 30, minus 2 plus r, it is 2r, so minus 1 divided by 3 raised to the power r, and x minus 1 times r, it is minus r. In here this x, the bases are same, so we have tr plus 1 is 15 cr, 3 by 2 raised to the power 15 minus r, minus 1 divided by 3 raised to the power r, and instead of the bases are same, this power and this power is added, 30 minus 2r plus minus r. So it would be tr plus 1 is 15 cr 3 by 2 raised to the power 15 minus r times minus 1 divided by 3 raised to the power r. In here we have 30 minus 2r and minus r, it is minus 3r. Now if you want to find the independent term of the x, so the x power should be 0. Why? Because if this one is 0, x to the power 0 is 1, 1 time this one, it is a natural number, or maybe integer number, and that integer number which doesn't have x, it means it is independent of the x. So 30 minus 3r should be 0. In here we have minus 3r is equal to minus 30, minus with minus, it's cancelled, divide both sides by 3, so you will have r is 10. Now it doesn't ask r. Which term is this one? Find the term. The term would be tr plus 1. So tr is 1, 10. 10 plus 1, 11. It is 11th term. It is not 10th term. It is 11th term. If you expand this expression, it would be independent of the x. I think you've got. Write it, please. By the way, it's sufficient for this lecture. Inshallah, we will have another beautiful lecture with the great examples for the next lecture. Allah Hafiz.